Good evening, minions. Welcome, we enthusiasts, to the next amazing marathon session where we are going to become from zero to hero in magnetism and EMI. So, first I'll be touching upon all the important formulas of magnetism and EMI, and then we'll be doing lots and lots of problems in the zero to hero series. So, the session will be about 2 hours till 9 o'clock. So make sure you keep the chat box clean, make sure it's free of spam, and make sure that the viruses are out. And make sure you keep the chat box active with all your lovely answers and all the lovely support that you give us every time. So all this with me, Shreyas, your master teacher for physics at Vedantu, going live. Hello everyone. Hello Nancy, hello Vinay, hello Andrew, hello Kartika, hello Modit, hello Yalini, Adi. Welcome. Hello Ritvik, hello Shruti, hello Ramesh, hello Priyal. Good evening everyone out here. Hello Devki, hello Jyotsna, hello Vrishika, NVD, Abhishek. Nice to see all of you over here. Hi Kashish, hello Vikram, Rajshekhar. Excellent. Yes, Master the Blaster is out here, and let's rock it, Vikram. Why not? You guys are here. So, those of you who do not know me, this is Shreyas here, and I have been training and coaching students for a very long time in offline, and then I moved to online, which is the Vedantu platform, and it is amazing out here because you can study right at the comfort of your home and choose your own schedule and choose your own courses at your own pace. So we decided to launch this YouTube channel so that a lot of students who are from the English medium can benefit from this channel, because this is an English channel, all right, for all the aspirants who want to crack JEE exams and other competitive exams for 11th as well as 12th. So I'm glad you guys are here. Make sure that you grow this community, and also you can know more about me on my Instagram handle, that is Shreyas_Vedantu. So before we begin, do not forget to smash that like button out there. And this is very important that you also share our videos and share our channel name with your friends, maybe on your status on WhatsApp or Instagram or Facebook, wherever you are, or just, tell about this channel, why it is important to, attend these classes live to all your friends in your school or class or coaching. And meanwhile, do not forget to hit the subscribe button in case you're new to this channel, because it is free of cost. Hello Ramki, nice to see all of you. Hello AK, Devendra, welcome. Hi Bhuvana, hi Jacob, hi Laksh, hi Vinay. Nice to see all of you. Yes, Sadi, why not spread? Like the yellow and orange color, it kind of tempts me because mango and orange flavors are really one of my favorite, in be it juices or be it other stuff. So I like the heart symbols out there. Thank you. Good evening, Mudit. Yes, let's begin. Laksh, thank you. So before we begin, this is the upcoming schedule for the week. Remember, tomorrow is going to be a very important thing. We are going to have the mock test, the third mock test, and then you are going to have a complete formula revision day after tomorrow, and then after that you are going to have sure shot 60 questions for JEE Mains. Very important schedule ahead, and in case you have missed any of the classes out there, do not forget that you can always check it out. You can always check it out in our past videos, and there is a special playlist created for all of you in case you have not seen that. So if you just go to JEE Enthuse channel, and if you go ahead and click the playlist out here, so you can see down here in physics, if you just click on physics, there is a separate zero to hero playlist where you can see all the videos which were conducted in the past few days. All right, and also guys, for any other chapter that you would love to study in detail, be it circular motion, momentum, SHM, fluids, capacitors, electrostatics, optics, modern physics, everything is out here. So do not forget to check out any of these lectures in detail. All right, there are lots of lectures for each and everything out here, so you can check it out. All right, everything for free. It's all there on this channel, so you don't have to worry about it. All right. Hello Abhishek, thank you for all the love and support. Don't worry, you can just leave a comment or ping me on Instagram, and like that many of your doubts have got clarified on Instagram. I have replied to many of the comments, many of the posts, many of the direct messages you have sent me. Also, I respond to all the comments that you put below on the videos after the video ends. So do not forget to leave a comment after the video ends. And those of you who want to join the crash course where you are going to get dedicated 45 classes before the April attempt, also you can watch these classes recorded. Each class is live, but it also gets recorded, so you can watch it n number of times. And also, if you want to get your doubts cleared from our doubt experts from morning till night, along with test series included in the package, along with handwritten notes, along with printed notes, along with assignments, along with lots of problem solving, and all the chapters will be covered from all the best teachers right from 11th to the 12th standard, then you should consider joining this crash course, which is going to start right now. So guys, go ahead, click on the link below in the description box. This crash course is for 10,000 rupees, but you get 30% off when you use the coupon code SHCC, and you will get it straight for 7,000 rupees. So go ahead, check it out, because I feel that this is going to definitely benefit all of you. So check it out and make sure that you do not leave any stone unturned for your next attempt of JEE Mains. So with this, let's begin with our preparation. Let's start with the formula slides, all the important stuff which is there in all these chapters. Welcome everyone. Yes, nothing piece, sure 60 is also going to be effective. All right. Yes, Adi Vlogs, I'm glad that this is going to be really of great help for all the English medium students out there, and definitely spread the message out there with all your friends. Now, here is the thing. Force on a moving charge. So let's start with forces on moving charge. If you have a charge which is moving with velocity v in a magnetic field, then the force due to the magnetic field, alright, so the force due to the magnetic field is given by QV cross B. So please understand, this much part is only because of magnetic field, alright, but if there is additional electric field, then there is this additional electric force which is Q into E. E is the electric force, so this is due to the electric field. So total force on the charges will be because of magnetic as well as electric field. Most of the times either one of them is there, but sometimes when both of them are there, then you need to consider both of them individually. Also, another thing you need to keep in mind is that this magnetic force never does work. The work done by it is always zero, because the force is always perpendicular to the displacement. Reason? Look at this, V cross B. So the force is V cross B, parallel to V cross B. So that means it is going to be perpendicular to the instantaneous velocity. Force and velocity are going to be perpendicular. That means work done by that force will be zero. Keep this in mind. I hope this is clear. Everybody understanding this? I hope everybody is understanding this. Great. Next, when a particle moves in a uniform magnetic field which is perpendicular, then it performs uniform circular motion. Very, very important. Uniform circular motion. So if you have magnetic field either this way or this way, and you throw a particle perpendicular to the field, it goes in a circular path like this. The radius is something you should remember, mv by qb. You should remember radius of that circular path when it goes. And time period 2 pi m by qb. The important part over here is it is independent. The time is independent, alright, independent of velocity. So no matter how fast you throw, the time period remains the same, but the radius would be different. Very, very interesting fact out there. Alright, Vinny, no problem. Join in. It's okay, I just started. Alright, interesting. Very good, Harry Parker. Don't worry, it's nobody can predict it, Harry Parker, because we are not here to guess. Whatever paper comes, we are going to solve it. And remember, everybody has to attempt the same kind of paper. So don't worry about whether it's going to be easy or moderate or difficult. Alright. Definitely, Karthika, I have just told you about it. Like, I've already unblocked, but in case you're still unblocked, don't worry. I'll check about it. I'll inform the admin team again in the night. Don't worry. Now concentrate. Alright. So, yes, Arjito Datta, you can definitely look at the trend. Okay, next thing, the force on a current carrying wire. If there is a current carrying wire, then the force is IL cross B, very, very important. And the magnetic moment of a dipole, of a current carrying loop, which behaves like a dipole, is given by IA and into N. So you can also add this N if there are more number of turns. This N is the number of turns. So the number of turns into current into A gives you the magnetic moment of a coil which is carrying current, because this coil carrying current behaves like a magnet. That's why a loop carrying current is an electromagnet. So the magnetic dipole moment is NIA. Keep this in mind. Also, the force on a current carrying wire is IL cross B. I hope this is clear. Mayank, I'm very good. Saurav, you are a little bit late, but just copy it down very quickly, and you can always rewind back in case you have joined in a little bit late and catch up at 2x speed. Okay. Last thing, very important property that you should know. This, not many people know this. If, guys, you have a wire which goes like this in a curved manner and there is current flowing in it, and let's say there is magnetic field also around it, all right, and you want to find the force acting on it. Remember, the force acting on a curved wire is same as the force acting on a straight wire. Keep this in mind. So you can just join a wire from the start till the end. So the force on a curved wire, all right, the force on a curved wire is same as the force on a straight wire. This is very, very important in a uniform magnetic field. Very important. I hope this is clear. I hope this is clear. Everybody understood this? Excellent. Yes, replace it with a straight wire. Excellent, NVD. Very good, very good, very good. All right. Great, great, great. Chalo. Shall we go ahead then? Everybody give me a yo if everybody is done copying, if everybody is done taking a screenshot, if everybody has written down or made notes. Everybody give me a yo out there. Yes. Very good, Yalni. Telegram ID, it's all there, Aisha, in the description box below. Just click on the link in the description box. Very good. Making notes, Priyal. Very good. Very good, Abhishek. Yo, excellent. Let's get going. Guys, lots of problems are coming ahead. First, I'm just brushing through the formulas so that, you know, the mood is set up, so that you know what are the important things and you have not missed any of the important stuff out here. Next, Biot-Savart's law. The magnetic field due to a current carrying element. Look at this. This one over here. This is an element of wire which is carrying current I. This is current carrying element. So at any distance from this element, what is the magnetic field? That is given by mu naught by 4 pi I dl cross r by r cube. Some people also write it as mu naught by 4 pi I dl, all right, r hat, r by r is r hat, and you will just put r square over here. This is a unit vector. R vector by r is unit vector. This also works. Keep this in mind. Okay. So this is Biot-Savart's law. Then field due to a straight wire, which comes via integrating this, is given by mu naught I by 4 pi d cos theta 1 minus cos theta 2. Well, you can use this, or better, you can do one more thing, guys. Remember that if this is, okay, if this is alpha, okay, and if this is, let's say, beta, instead of this, what you can remember is B is equal to mu naught I by 4 pi d. D is the distance from that finite wire, and then you can put, guess what you should put? Sine. Yes, you can put sine theta 1 plus sine theta 2. Oh, sorry, alpha, my bad. Sine alpha plus sine beta. This is a better form of remembering rather than this. If you don't like this, it's okay. All right, you can remember this. This is easy to remember. Remember, for infinite wires. So for infinite wires, what will happen? The wire is infinitely long. The angle which is subtended at this point, alpha and beta, will tend towards 90. So for infinite wires, alpha and beta will be 90 degrees. This is what you should remember. Okay, very, very important. Yes, this is better than remembering this, because remembering theta 2 and theta 1, they are exterior angles. It is slightly confusing. So it's up to you which one you want to remember. Next, field due to an infinite straight wire. So this is what you get when you put alpha and beta both as 90 degrees. Keep this in mind. So this is what you get when you put alpha and beta both as 90 degrees. Now, this is also very important. The force per unit length, there are questions on this today. We are going to see how many of you are going to remember. The force per unit length is mu naught I1 I2 divided by 2 pi d. Remember, mu naught I1 I2 by 2 pi d, but there is a small catch over here. Keep this in mind. If the currents are moving in the same direction, they are not going to repel, they are going to attract. Keep this in mind. What are they going to do? They are going to attract. And if they are going in opposite directions, only then they are going to repel each other. So opposites attract, opposites repel, and same directions, all right, they will attract. Keep this in mind. It's reverse of what it is for charges or magnets. Keep this in mind. Very good, Jatin. You are just watching semiconductors, no problem. So you can just probably attend this lecture live, and later on you can watch all the past videos. They are not going anywhere. Trust me guys, watching a lecture live is a very different experience out here. Deepika Pardeshi, bacha, don't worry. Whatever you feel, please put it up in the comments after the video ends, or ping me on Instagram. My Instagram handle is Shreyas_Vedantu. I have been responding to a lot of queries recently, so please post your query out there. Definitely I will do it. Okay, don't worry. Okay, yes, you can find the direction of the force using cross product also, Rishabh. Yes, correct. Very good, Abhishek Crystal here. Okay, Andrew, everybody has written it down. Can we move ahead, minions? Can we move ahead, minions? Let me know. Let me know. Okay, let's go ahead to the next slide out here. Okay, so the next slide out here, field at the center of an arc. Very, very important. If there is a coil carrying current, all right, so only if an arc is considered, then the formula is mu naught I theta by 4 pi a. Actually, it comes from this only. So if it's a complete ring, all right, if it's a complete coil, then it is mu naught I by 2a, correct? It is mu naught I by 2a for a ring. Now this, if you multiply by theta by 2 pi, you are going to get this formula. Check this out. Theta by 2 pi. What is this theta by 2 pi? It is the fraction of the angle. Fraction of the angle subtended by the arc. Keep this in mind. This is the fraction of the angle subtended by the arc. So that's it. So 2 pi radians produces this much field. If it is theta radians, how much will it produce? Unitary method. That's what is going to give you this answer. Is this clear? Yes, Rishabh, you said it. Unitary method. Correct. Angle subtended at the center. Very good. Hi Tarun, join in. Yes. Gautam, you should watch all the PYQ, all the 0 to hero series plus mock test and the formula revision plus self-study. If you do that, definitely it will be good for your JEE March attempt. Definitely. Thank you, Ati Gopi. Love you too, beta. Hello, Madhusudan Reddy. Welcome. Hello, Dhrumil Shah. Hello, Aditya Thakur. Join in all the new minions out here. And guys, you can become a free member of this channel by hitting the subscribe button. And please show your love and support by hitting the like button. Guys, this is Shreyas here. We are doing a marathon session of 0 to hero of magnetism. First, we are looking at all the important formulas, and then slowly we are going to move to problems. Lots of questions coming up slowly now. Next up, Ampere's law. B dot dl is equal to mu naught I enclosed. Very, very important. So, a lot of people get confused what to do in these cases. Let me tell you. So, for Ampere's law, guys, see, if there is a current coming towards you, and if there is a current going away from you, again current coming towards you, again going away from you. So, there could be many currents, I1, I2, I3, I4, etc. You first choose a loop. So, you need to choose a loop, a path. This is nothing but a closed path. So, you need to choose a closed path. That's why the cyclic integral. So, let's say I choose a closed path like this. Okay. So, at every point, all right, at every point, there will be some distance covered, which will be dl. And you are covering this complete loop by moving dl, 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 dl like this. And at every point, there will be some magnetic field. Okay, there will be some magnetic field out there. Okay, so that, let's say that is B vector. So B dot dl at every point, if you do it, that value of the integral comes out to be mu naught into the enclosed current. What is the enclosed current? I1 and I2 only. I3, I4 are not enclosed current. So keep this in mind. This part, whatever currents are there in this part only should be considered for the right hand side of Ampere's law. Keep this in mind. Okay, very good. Yes, this is Maxwell's modified equation. Correct, Jasima. Glad to know we have followers, we have supporters from Uttarakhand too. Love you too, Ganga. Glad you guys are here. Hello, welcome everyone. Rishabh, this is a very important high frequency chapter. Lot of questions came in the February attempt from this chapter. That's why it's a high frequency chapter. Lot of questions are going to come, mark my words, even in this particular attempt. Field inside a solenoid mu naught Ni, where small n is nothing but turns per unit length. So for a long solenoid, the field is uniform and it is given by this formula. Similarly, if you take a solenoid and bend it and connect their ends, it becomes a toroid. So solenoid converted into circle is a toroid. The formula is the same. You can see this mu naught Ni. Here number of turns per unit length is turns upon the length of the solenoid. What is the length of the solenoid? 2 pi r, where r is the radius of this circle. All right, that's it. I hope this is very, very clear. MD Sina, don't worry, this is Shreyas here. I'm the physics master teacher. So this channel is for all the English medium students out there, and we are preparing for the upcoming March and April attempt. These are high frequency chapters and we aim to go from zero to hero through these sessions, and we are going to solve a lot of questions out here. So go ahead, hit the subscribe button, and Hari Prasad and NVD and Anvesha. So Hari Prasad, NVD, Anvesha, don't worry beta, focus on the session right now. Please post in your queries after the session ends below this video, or ping me on Instagram. My handle is Shreyas_Vedantu. I'll help you out. Now, for now, please focus on the session. All right, let's get moving to the next part. All right, field due to a bar magnet, very, very important. All right, Simran, whichever part you want to repeat, please watch the replay again. Please watch the replay again. Okay, great. So even during a live session, you can just rewind back and watch it again. So don't worry about it. Okay, cool, cool. Now, field due to a bar magnet. Now there are two positions of a bar magnet. A bar magnet has a dipole moment. What is this M? This is a dipole moment of a bar magnet. So keep this in mind. This M that you see over here is dipole moment of a bar magnet, and that M is pole strength into the magnetic length. This M is nothing but the pole strength. Keep this in mind. Very, very similar to electrical dipole moment. This L is nothing but the magnetic length. So this is nothing but the magnetic length of that particular bar magnet. There are two positions, B1 and B2. B1 is called as the axial position. All right, axial position, and this is called as the equatorial position. Keep this in mind. So at the equatorial position, it is mu naught by 4 pi m by d cube. All right, but on the axial position, it is mu naught by 4 pi 2m. There is a 2 extra over here divided by d cube. Keep this in mind. Anvesha Bicha, like I just said, please post all your comments or message me on Instagram. During the live class, it's difficult to address to each and every of your every query of yours. So please post it. Like you all have seen, I respond to all the queries, whatever you guys ask. Okay? Yes, Kavya, I'm going to do this for thermodynamics also. So, yeah. So Harsh, basically for the field inside a magnet, you have to treat it like a solenoid. It's something like a solenoid. It's like an electromagnet. So very similar to a solenoid. Okay, cool. What is the difference between Ampere's law and Gauss law, Jyotsna? The thing is, see, in Ampere's law, you integrate field. All right, you integrate field with respect to distance, correct? In Ampere's law. But in electrostatics, you integrate field with respect to area, correct? That's one major difference on the LHS, correct? And on the RHS side, in electrostatics, correct, it is the enclosed charge by epsilon. But in case of magnetism on the RHS, it is mu naught into I enclosed, current enclosed. So that's the major difference between them. So keeping this in mind, if you try to compare both of them, you can easily in fact remember all of these things. All right, all right. So D is the distance from the center. If you're wondering what this D is the distance. Yes, D is the distance from the center. All right, from the center. Keep this in mind. So D is the distance from the center of that dipole. All right, very good. Excellent, Harsh. Excellent, Abhishek. Very good. I hope this is clear, Andrew. Yes. Okay, very good. Sir, can you explain why the magnetic field form continuous closed path but electric field does not? Well, see, these are the things which come out by experimentation. Like, there is no reason why magnetic field behaves this way. I mean, in fact, I can ask you the same question, Jasima. Like, why is it that the masses are only attractive? Why don't they repel each other? Why should two like charges repel each other? Why should unlike charges attract? So, that's one thing. Second thing, the basic explanation, Jasima, is that magnetic monopoles do not exist. Okay, so you cannot separate out north pole and south pole of a magnet. So that's why they always, form continuous loops. They never terminate. Whereas charges have positive and negative values. So they can start from some point and they can end at some point. So that's why they terminate and originate, unlike magnetic fields. I hope that is clear. Alright, thank you, Ayush. I hope that makes some sense, Jasima. Alright, excellent. Let's get going. Earth's magnetism, well, it's not so important because it's in the optional part. For you guys, this part, whatever I'm teaching, is very important. Next up, okay, other things that were there over here, torque M cross B, standard, just like electric field, electric dipole. Torque on electric dipole is P cross E. Here it is M cross B. All right, and energy is minus m dot b. In electrostatics it was minus p dot e. Same thing out here. Okay, hello Jupudi, welcome, join in, welcome. All right, let's get going to the next part. EMI, magnetic flux. Just like electric flux, it is b dot ds. What is this ds? This ds is nothing but the area. All right, it's just like electric flux. So if you have some area over here, okay, if you have some area over here and you see that some magnetic field lines are passing through it, all right, the magnetic flux is directly proportional to the number of lines, be it electricity, be it magnetism. The flux tells you how many lines are passing through a given, piercing through a given area. All right, next up, Faraday's law. The rate of change of this flux gives you the induced EMF. I'll repeat, the rate of change of flux. This is nothing but the rate of change of flux. So if the flux does not change, even if you place a very strong magnet, if you do not move it, if you do not turn it, if you do not change any of the things, then there will be no electricity produced. Only changes in the flux produce electricity. Keep this in mind. Now the minus sign stands for this direction, the Lenz's law. So keep this in mind. Keep this in mind. So PK Many, hold on, everything will be uploaded. Like I said, look over here, please read this instruction carefully. Okay. Now the Lenz's law says that the direction of the current always opposes the change. This word many people forget. It always opposes the change, not the magnetic field. Many people get wrong or lose marks or get a negative marks because of this word. So keep in mind, if there is a field and if that field is becoming stronger, then the induced field will try to oppose the increase. If the magnetic field is trying to increase, then the induced current will create induced magnetic field to oppose the change. So what is the field trying to do? Increase. So it will try to oppose it by trying to weakening it. All right, it will try to weaken it. Similarly, if the magnetic field is becoming weaker and weaker, it will try to stimulate it. It will try to create a magnetic field to strengthen it. So it always opposes the change. If it becomes strong, it makes it weaker. If it becomes weaker, it tries to make it strong. This is what is very, very important. No problems, Neha. Just join in, beta. I have just completed the theory part of this. All right. So please watch the replay in case you feel like revising all the theory part, because it's very important. Also catch up at 2x or 3x speed out there. Okay. Cool. Let's get going. And last one, motional EMF, E is equal to BLV. But there is a modified formula for this. The induced EMF is B dot L cross V. This is in vector form. It's a scalar triple product. Take the cross product of any of the two and take a dot vector with magnetic field or anything else. Okay, so this is something which you can use or write it like this. L dot V cross B. So just write it like this. This is better. L dot V cross B, because you have been used to writing V cross B even in the force formula Q V cross B. So instead of Q, you put L. That will give you the induced EMF. Very important formula for vector form in motional EMF. Okay, all right. Acha, max is 2x. Okay, koi baat nahi, Gaines music. So catch up, Sneha, at 2x speed. All right, cool. What is motional EMF, Mudit? See, if you take a rod and move it in a magnetic field, there is EMF induced in it. So that is called as motional EMF. Why is the EMF induced? There is a reason for that, because when you move a conductor, that's when, you know, what will happen? The charges will experience force due to the magnetic field. So the charges get accumulated on one side and they leave some other part. So once the charges get accumulated, there is a potential difference which is called as the induced EMF. So that's where it comes from. Okay, very good. So let's get going. I hope this is clear. L means what, sir? L is the length. L is the length. L is length. V is velocity. B is magnetic field. So if you move a rod of some length, all right, this is L, moving with some velocity in some field, the EMF across the ends is given by this particular formula. All righty, let's move ahead then. All right, very good. So if you guys are ready, shall we go ahead? Yes, this is inductance, last part of today's theory part, and then we'll move to the problems. Self-inductance. Flux is Li, all right. The flux associated with a coil carrying current, if it is written down as something into current, that constant is called as self-inductance. And when you differentiate this, when you differentiate derivative, if you take the derivative, remember, derivative of flux is EMF. d phi by dt is EMF. L is a constant. di by dt is the rate of change of current. Okay, so this is self-inductance, very, very important. Keep this in mind. Next, self-inductance of a solenoid, standard formula. This is very, very important, guys. Mu naught n square pi r square L. Very, very important formula. Keep this in mind. Yes, magnetic flux. Yes, obviously this is magnetic flux. So if you have a coil which carries current, all right, so through its own area, all right, there will be some magnetic field lines cutting through it. So that flux is this phi, this current is this I. So if flux is proportional to the current, which is true, that constant of proportionality is called self-inductance. So more the current, more the field lines. So that constant of proportionality is called self-inductance. And that self-inductance for a solenoid is mu naught n square pi r square L. N is turns per unit length, R is the radius of the solenoid, L is the length of the solenoid. Is that clear? Okay, cool. Let's get going. I hope, Jasima, that's fine. Very good, Abhishek. Yeah, hello, Senthil, join in. So what is di by dt? Di by dt is rate of change of current. So this is nothing but rate of change of current. Keep this in mind. This is rate of change of current. Okay, is that clear? No problem, Senthil. Just join in. You can just replay back whatever parts you have missed and join in. Catch up at 2x speed. Next, energy stored in an inductor, standard formula, half L I square. If there is current I flowing through it, then the inductance, if it is L, energy is half L I square, standard formula. Energy density, energy per unit volume. Just like in electric field, it was half epsilon naught E square. So instead of E, you have B. And wherever you have epsilon, all right, replace it with mu naught, but it will come down. So that is how magnetism and electricity works formula wise. If something like epsilon naught comes in the numerator, mu naught will come in the denominator. If epsilon comes in the denominator, mu naught will come in the numerator. Always it goes opposite. So keep this in mind. Very, very identical to energy density formula of electric field. You can just compare it and remember it. Okay. So this is another important stuff. Energy per unit volume, that means it will be in joules per meter cube. Remember, this is just energy which was in joules. This is per unit volume. Keep this in mind. All right. ASN, the class starts every day at 7 o'clock. My class always starts at 7 o'clock. All right. So this is a 2-hour class till 9 o'clock. All right. Which is a marathon session. Next, mutual inductance, just like this one. So if there is a coil which carries some current, all right, and there is another coil over here, all right. So this coil will produce its magnetic field, and some of the magnetic field lines are going to pierce through it. So some magnetic field lines are going to pierce through the other coil's area. So remember, the flux in the other coil is proportional to the current in the primary coil. The flux in the other coil is directly proportional to the current in this coil, because if you increase this current, what is going to happen? More number of field lines are going to come. Correct? More number of field lines are going to come, and proportionately the flux in the other guy will increase. So that constant is called as M. And again, if you differentiate this, d phi by dt is EMF, M into di by dt, just like here it is rate of change of current. I hope this is clear. I hope this is clear. Very good. Okay, let's get moving. Very good, Sanjay. All right, let's pump ourselves. Very good gains. Yes, last slide. An EMF induced in a floating coil which is rotating. Sorry, I don't know. Yeah, rotating coil, my bad. So EMF induced in a rotating coil is Born sine omega t, BA omega n, standard formula. If you take a coil, there is a magnetic field. If you rotate the coil, the induced EMF is Born sine omega t, because the field lines piercing through the coil will continuously change as the coil rotates. So there is change of flux, and by Faraday's law, there should be induced EMF. So this value is given by BA omega n sine omega t. B is magnetic field, A is the area of the coil, N is the number of turns, omega is angular speed, and sine omega t, that means it will keep on changing as it rotates. So it's a variable, it is a function of time. Okay. So Mudit, what is the difference between mutual and self-inductance? You studying at home, all right, and you learning is self-inductance. Me teaching you out here is mutual inductance. Similarly, if there is a coil and the current in the coil changes, that change in current creates EMF in that coil. That is self-inductance. Similarly, if there is a coil and the current in this coil changes, because of which there is electricity in the other coil, that is called mutual inductance. I hope that is clear. Okay. Yes. So energy stored in an inductor will be zero if any of these terms will be zero. Either the inductance is zero or there is no current only. All right. I hope this is clear. Harish Krishnan, I hope this is fine now. All right. Very good. Very good. Very good. Yes. Questions will also be explained. Yes. Let's get going. All right. So I'm going to erase this now. And before we go ahead, remember you guys are also preparing for Ekalavya batch, which is your next step after mains to crack the JEE Advanced. This Ekalavya batches are going to start at multiple points, and there are multiple entry points into this batch, so you can clear JEE Advanced. Last year from the Ekalavya batches, we created more than 500 All India ranks just from Vedantu, who cleared JEE Advanced, which is a huge achievement. There are lots of test series, lots of mock tests, lots of assignments, doubt solving, obviously from the best teachers. And in fact, last year I was also a part of Ekalavya. So guys, all the good teachers are out here. So don't worry. Multiple entry points, 19th March, 1st May and 29th May. In case you have missed this, don't worry. Please fill up the form which is there in the description box below. And these batches are all for free. I'll repeat, these batches are for free of cost, and there are limited seats. So if you have got 96, 97 percentile and above, then you can get entry into these batches after filling up the details in the description box below. There is a form, fill it up. And in case your percentile is not that great, let's work harder so that you can get into Ekalavya batches. How many of you feel that you can make it into Ekalavya batches? Uday Gamer, whatever your doubt is, don't worry. Please post it up in the description box, in the comment section after the video ends. Definitely I'll help you out. Sakti, no problem. No problem. Yes, Anvesha says yes. Let's get up. Yeah, you guys are going to get into Ekalavya batch. Let's work harder. Yes, wow, Anish is already a part of Ekalavya batch. Glad. All right, all right. So, wow, very good Sneha. If you got 99.91, you should definitely fill up this form. Very good Modit. Very good Priyal. Very good Sanjal. Very good Ajal Kumar. Very good, very good, very good, very good Shashank. You're already a part. Let's get going, Ishika. Yes, very good. Alrighty. Random mail, no. You have to work even harder. That's why you are here. Don't worry, we'll work harder random mail. Okay? Chalo, let's get going. Very good, Harsh Krishnan. And here's the first question up on your screen. Okay, let's see how many of you are going to get this. The net magnetic moment of two identical magnets, each of magnetic moment m naught. This line has come extra, just ignore that. It is just m naught, guys. There is nothing over here. Inclined at angle of 60 degrees to each other is which of the following? I'm going to give you some time. Let's see how many of you are going to get it. Don't worry, Sakti. We are trying harder, right? So don't worry. Is any mock test for March? Yes, Amnesha. Tomorrow itself, we are going to have a mock test on this channel. Okay. Thank you, attitude level. All right, Abhishek says C. So P centil. So if you have same change in current, then which one will have more kind of EMF induced? Well, it depends on M and L. A lot of people feel that L is more than M or M is more than L, but there is nothing like that. It could be anything. So it completely depends on L and values of M. So it is a dependent thing. A lot of you are saying C. Okay. So Uday Gamer, why don't you ping me on my Instagram handle? Alright, I'll definitely help you out beta, or post a comment after the video ends. So well, it's very simple, guys. What you need to do is remember magnetic dipole moment. Alright, magnetic dipole moment is a vector quantity. M naught and M naught. The resultant is going to be M. The angle between them is 6. So the resultant will be, use the vector formula, A square plus B square plus 2 into A into B into cos theta. That's it. All that I've done is use the vector addition formula. So M is everywhere. So I'll just put M naught outside. M naught square, M naught square, M naught square. When it goes become M naught, you'll have 1 plus 2. Cos 60 is nothing but half. So that's it. 1 plus 1 plus 1 is root 3. So it will become M naught into root 3, which is nothing but this particular option. Very good. You just remembered NVD. No, Josna, it should not be buffering, I guess. Very good, Abhishek. So Sumal, Sumna, Akhila, very good. Excellente. Very good, Sneha. Very good, Pooja. Very good, Modit. I can see all your past answers. Very good, Bhumna, Lily, Mr. Nani. Very good, Sakti. Excellente. So that's the correct answer, guys. Very good. Let's move ahead then. Yes, this kind of questions can come in JEE Mains. Believe me, these kind of questions in fact have come in JEE Mains. Though you might feel that these are simple, but actually they can come. So that's why I'm boosting up your confidence. I'm making you revise all the important things through this chapter, or through these sessions, sorry. Okay. Also, there was a question like this before. It was given that there is a curved magnet, a horseshoe magnet. This was south pole, this was north pole. What is the magnetic moment because of this? Guys, understand, even though it is curved and even if the radius is r, at the end of the day, this is equivalent to just this magnet where there is a south pole and there is a north pole, and the length of this magnet will be 2r. Okay, so this is the effective length of this magnet. So you can convert this magnet into this magnet to find the effective dipole moment. Keep this in mind. Yes, this is how things have to be done. Very good. Let's move to the next one. If a bar magnet of pole strength small m and magnetic moment capital M is cut perpendicular to the axis, now you think what it means, into two equal halves, then the new pole strength and the new magnetic moment are respectively. Let's see how many of you are going to get this. Come on, minions, let's do this. Very good, let's do this. Come on, minions. Very good, Hari Krishnan, you got it. Come on, attitude level. Come on, Sakti. Come on, Sneha. Come on, Abhishek. Come on, Jasima. Come on, Sobia. Come on, everyone. Come on, minions. Okay, Chandramoli says B. Shruti says B. Very good. Jyotsna says B. Nani says B. Priyal also saying B. Okay. Well. Interesting. Manu Elite saying B. Jasima saying B. Okay. Well, the correct answer is, see, if you take a bar magnet and divide it into two halves, such that it's cut perpendicular to its axis. What is the axis? This is called as the axis of a bar magnet. Perpendicular to that, that means this. So you cut it like that, you will get two bar magnets which are smaller in length. Alright, so this is the meaning of that. So keep this in mind, guys. This is basically the axis and this is nothing but the equator. So this is the equator of a bar magnet. Now what will happen? This north and south pole, when it is cut, you will get two new south and north pole. If the pole strength was M and M, alright, M and minus M, now it will be M, minus M, plus M, and again minus M. So you will see that the pole strength hasn't changed. So pole strength will remain unchanged. So obviously C option and D option are wrong. Alright, here the pole strength has changed. But remember, the magnetic dipole moment, alright, was M into L. Now the new magnetic dipole moment will be M into L by 2. So it is the previous magnetic dipole moment by 2 because the length has become half. The the magnetic dipole moment depends on the length. So if you make the length half, the dipole moment also becomes half. So hence B will be the correct answer. Very good. Very good. Very good, minions. You guys have nailed it. Very good. I'm pretty sure if these kind of questions are going to come, and I'm pretty sure these kind of questions will come also, then you will definitely remember this session and you will thank me and you will thank this channel as well. And plus 4 marks just freely available in your pocket, which will boost your rank by a couple of hundreds, if not thousands. And that's it. It's going to be a deciding factor. Each question is going to add 4 marks in your kitty, and that is going to make a huge difference. So pay attention till the end. Let's move on. Okay, so that was the correct answer. Let's move on to the next one coming up on your screen. A short bar magnet of magnetic moment 0.4 joule per Tesla is placed in an uniform magnetic field of 0.16 Tesla. The magnet is in stable equilibrium when the potential energy is, what is the value of potential energy when the magnet is in stable equilibrium? The options are here up on your screen. Thank you, attitude level, glad. Okay. Okay, somebody at least praising my hairstyle. Come on, come on, come on, minions. Come on, 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 come on. So Chandramouli, if you cut it along the axis, then the pole strength will become half, but the magnetic dipole moment will become half because the pole strength became half. Okay, Chandramouli? So pole strength will also become half. North will get divided into 2 parts, but length remains the same. So the magnetic dipole moment will become half because of the pole strength becoming half. Okay, cool. A lot of you are saying C. Well, that I don't know. Well, I'll tell you what. See, first of all, this is a bar magnet like this or like this. So in this case, if this is the external field, in this situation, understand the magnetic dipole moment is in the direction of the magnetic field. Here it is opposite to the direction of magnetic field. So this is basically unstable. It is unstable, and this is the stable equilibrium. And in stable equilibrium, theta is 0 degrees. And what is the formula for energy? It is minus m dot b, right? I just told you. So it is minus mb cos theta. Now just substitute the values of m and b. M is 0.4, okay, b is 0.16, cos theta, well, that's cos 0. Cos 0 is 1, and you are going to get it as minus 0.064, and that is going to be option C. Very good, minions. Mayank, no, it's not B. Priyal, no, it's not B. Very good, NVD, Nani, Priya. Yes, Aishwarya, correct. Very good. Now you guys have got it. All right. Yes, Jyotsnam, minus BM cos 0. Very good, very good. So NVD, I think you first said D, but now I hope you got it. Excellente, minions. Excellente. Very good, Samla. All right. Let's move on to the next one. So you can see the correct answer is minus 0.064. Very good. Very good, Samla. You said it first. All right. So attitude level is on fire. So guys, if you still have any doubts, do not forget that you can ask us anything in the comment section, or you can ping me on my Instagram handle. But first show your support by following me on Instagram or by subscribing and loving this channel. All right, let's move ahead to the next one. The midpoints of two small, very difficult but tricky yet not so long question. Very good question this is. The midpoints of two small bar magnets, all right, of some small length d are in end-to-end positions. That means there is north-south here, there is north-south here, end to end. So, but they are very far. If there is a bar magnet here, the other bar magnet is here. The length of the bar magnets is d and it is very small as compared to their separation, which is x. Then the force between them is proportional to some power of x raised to minus n. So basically inversely proportional to x raised to something. So what would be the answer? So Ramki, the angle in unstable equilibrium will be 0 degrees beta. So if like you take a magnetic needle, what does it do? It will try to align itself in the direction of Earth's magnetic field. That's when it is stable. So theta is 0. But if you take the magnetic needle and turn it, it will flip. It is going to be unstable. So in unstable, theta will be 180. Stable, it will be 0. Alright, Shruti saying D, Mayank saying 4, Sneha saying 4, Annapurna saying 4. Wow, Annapurna, that name is very nice. I mean, like, it reminds me of a restaurant very close to my hometown, and we used to go there when I was a student, and it used to always make me hungry because my coaching institute was just above that Annapurna hotel, and I used to always smell the nice food from that Annapurna hotel, and I was never able to concentrate, so it was very difficult. Oh, was it Annapurna or was it Anupama? Okay. Okay, I read it as Annapurna. Anyways. Okay, a lot of you are saying 4. Now let me tell you how this works, guys. Okay. So first of all, what you need to do is basically, due to one magnet, what is the field on the other magnet? So what is the field due to other magnet over here? So what is the value of B? Well, I just gave you the formula of B, guys. It was something, doesn't matter what is that something, okay? Something divided by distance cube. Remember, it was distance cube. Doesn't matter what the constants were, because we are just wondering about what is it proportional to. Okay. Now, because of this guy's magnetic field, this bar magnet, which has its own dipole moment, will have some energy, and that energy will be minus mb and let's say cos 0. Okay, so it will be nothing but minus m multiplied by something which I don't care, okay, divided by x cube. Now once I get u, this u can help me figure out the force acting on this magnet because of this magnet's field, and that is going to be given by this formula, minus du by dx. Negative of du by dx. Yes, very, very important. Yes, very, very important. So minus du by dx, very important formula from work power energy. So if you differentiate this, these all things are constant. So minus m, minus and minus will in fact become plus, this minus and this minus. So plus m multiplied by something, okay, multiplied by derivative of, all right, derivative of x cube, but it is below, so x raised to minus 3. So what will it be? It will be nu something, I don't care, some constant, all right, and derivative of x raised to minus 3 into x raised to minus 4. So it's constant, and what should matter is x raised to 4 will come below. So it is basically 4, which is the correct answer. Very good. Understood? So this is how it works. This is how it works. Excelente. Excelente. Many of you got it. Very good. But this is the correct method of doing it. Very beautiful technique. I did not worry about the constants. I just focused on the proportionality. And I also remembered force is du by dx. So no complicated maths out there. Okay. So that's the answer. Very good, Yalini. Understood. Very good, Anjali. Kumar. Okay. Ajay Kumar. Sorry. Very good, Modit. Very good, Mayank. Very good, Sanjay. Excelente, Abhishek. Very good, Hari Krishnan. Let's move ahead to the next question coming up on your screen. A 25 centimeter long solenoid which has some radius of 2 centimeters and 500 total turns, it carries a current of 15 amperes. If it's an equivalent to a magnet of the same size, and you have been asked the magnetization. Now, if you have forgotten magnetization, well, it's magnetic moment per unit volume. Magnetic moment per unit volume. What is the magnetic moment per unit volume? Very interesting options. Let's see how many of you are going to get it. Very good, Jyotsna, you got it. Very good, Aishwarya. All right, Anuj Gamer. Very good, Priyal. Come on, minions. Let's see how many of you are going to do this. Let's see. Sir, is the same PPT in Hindi also? No, Rajshekar, this is an English channel, so it will not be available in Hindi. I'm afraid so. Okay, so a lot of you are saying S. Ramya, this is for 12th standard. Well, Sneha, Jai Krishna, Manulite saying C. Very interesting, very interesting, very interesting. Guys, let's become a hero today from zero in magnetism. Is a very important high frequency chapter. Most of the questions from my experience have come from whatever sessions I have conducted. And if you have been attending my sessions regularly in January and Feb, you know a lot of questions in February came from the sessions I conducted. So attend this session properly. You never know which question is going to come, at least via concept. So this is going to be our free 4 or 8 marks in your KT, which is going to boost your ranks out there. Come on, keep answering, keep interacting. A lot of you are saying C, I believe. All right. So let's do this. It's not that difficult. So first of all, what we need to do is let's use the formula. So the magnetization, all right, is nothing but magnetic moment, okay, per unit volume. Now what is the magnetic moment? N-I-A. Remember, I just told you magnetic moment is number of turns into I into A divided by volume. What is the volume of a solenoid? Area into the length, correct? So if this is the area of the solenoid, this is the length of the solenoid. So the area multiplied by the length gives you the volume of the solenoid, cylinder, right? So AA goes off. So it will be Ni by L. Now it's just plain simple substitution. N is 500, current is 15, and length, where is it? 2 cm. Oh no, radius is 2 centimeter. This is 25 centimeters. So 25 into 10 to the power minus 2. So 5, this will become 3, and this will become 5, this will become 100. Okay, so this should become 3 multiplied by 100 divided by 10 to the power minus 2. So it will become 3 into 10 to the power 4. So 4 zeros. Where are the 4 zeros? Here. Yes, this is the correct answer. Very good, very good. Yes, very good. Excellent, minions. Excellent. Very good, Niranjana. Very good, Rahul. Ram. Join in. Okay, let's move ahead. Very good, minions. You guys are performing fabulous. The way you guys are doing, I am feeling confident that you guys are going to rock it just because you have been attending these series of Zero to Hero. Believe me, guys, just by attending these sessions, even on YouTube, all right, and attending everything properly live, all the lectures, Zero to Hero, mock tests, formula revision, all the chapter lectures which I have conducted. Believe me, and if you have studied well, and if you have followed the books which I have told you, if you have followed all the instructions which I have told you, believe me, nobody will be able to stop you. Nobody, nothing, even an earthquake, even I don't know, no villain, no teacher, no student, nobody can stop you from scoring well. Believe in yourself, you are going to do it. Let's move ahead to the next question coming up on your screen. There is a straight conductor of length L, okay, carrying current I, and it is bent in the form of a semicircle. The magnetic field in Tesla at the center of the semicircle is, let's see how many of you are going to get this. Wow, Niranjana, it's your first live class. Glad to see you, and I hope this is not going to be your last. After this, you're going to attend each and every class live. Believe it, you're going to ace it. All right. No, magnetic momentum is different, Andrew. Though the formula, the symbols could look same, but they are two different things, okay? So it will be mentioned what are they talking about, Andrew, so don't worry about it. So Sneha, the books that you need to study from is previous year questions from Arihant, HC Verma and Tattva module, or the assignments which Vedantu provides, along with whatever PDFs we give you at JEE Enthuse. More than enough. That's it. HC Verma, previous year questions, alright, Arihant book, previous 40 years chapter wise, and the Tattva module or the assignments which Vedantu gives you, along with the PDFs which we give you for free on this channel. More than enough. That's it. Okay. Correct. Nothing else you need. Nothing else. If somebody has told you, you should buy this, you should buy that, ignore. Don't need. Okay. Let's see. A lot of you are saying B. Some of you are also saying C. Yes, Samla. Correct. PYQs of Arihant. Very good. HCV for concept as well as problems, Samla. Both. Abhi Gamer says B. Abhi Gamer, do not spam beta. Do not put it so many times. Just put it once. Oops. Okay. I didn't catch that. Oh, my Siri. All right. Okay. So I'll tell you what, guys, how you need to do this. This is a wire of length L, right? You bend it into a semicircle. So there will be some radius. Remember, this length will be the circumference. And what will be the circumference? Pi r. Correct? Okay. Next, what will be the magnetic field over here? Because of this wire carrying some current. If this wire is carrying some current, what will be the value of the magnetic field? I just gave you the formula. It is mu naught I by 2r. Okay, 2r, but it's a semicircle. Be careful. If it was a complete circle, this is the formula. For semicircle, it will be exactly half, because each half will contribute something. So the contribution of one of the halves will be half of the complete circle's contribution. That's it. Now it's just substitution. Mu naught, well, I can put it as, oops. Okay, so mu naught is nothing but 4 pi into 10 to the power minus 7. Current is current. Okay, now 2 2s are 4. Radius from here. What is the radius? Length divided by pi. It's length divided by pi. 4 goes away. All right. So I hope you see that over here very clearly. So 4 and 4 has gone, and the only thing left is pi square into 10 to the power minus 7, and obviously I is also there, divided by L, and that should be this option A. Check this out. Many of you are wrong, I guess. Many of you are wrong. Check this out. Yes, a lot of you got it wrong. Many of you said B. Some of you said A though. Okay, Mayank said A. Very good. So Subhash, it should be released by today or tomorrow. Okay, so I wouldn't know it, right? Very good. So how radius came, Abhi Gamer? From here. Remember that same wire was bent into a semicircle. So if you take that wire and bend it into a semicircle, the perimeter will be pi r. 2 pi r is for the complete circle. So length of the wire is pi r. That's where you got the radius from. Okay, I hope that is clear. Very good. Sneha, I have completed YDSC in my regular flash series in detail, but 0 to hero will come very shortly after the March attempt. Okay, got it? Very good, Nancy. Let's move ahead. So that's the correct answer, option A. A lot of you got it wrong, but it's okay. You have come here to learn. Do not feel demotivated. Learn and accept and improvise. Believe you will do well. Okay, next question coming up on your screen. A current is flowing through the loop as shown like this. Remember, this is R, this is 2R. Oops, I just showed the answer. My bad. This board is very sensitive, very sensitive. So, okay, this is R, this is 2R, and the current is flowing like this. The question is, what is the magnetic field at point O? Hello, Asmi. Hello, Hari Krishnan. Thank you for all the love from Kerala, Bacha. Lovely state, lovely place. No winner class PDF is obviously not going to be enough. You have to learn more from the books and practice a lot apart from the PDFs. This is just one thing which we give you for free. I mean, you have to buy the books, H.C. Verma, Arihant and all that. All right, now everybody is going to get D. Oh, by the way, guys, you know what? In my regular sessions, I just did one experiment. I showed them the answer. You won't believe what I'm going to say. I gave them the answer, that the answer is, let's say, D, for example. And I told them, okay, I'm going to conduct a quiz now, and let's see how many of you are going to get it. And believe me, not 100% of the people got it. I told the answer is D, please press on D, and nobody got it. It was like 98% of the people got D, 2% still marked the wrong answer. And I was like, what the hell, man? Come on, I just gave the answer. So I was like, okay, let's do this again, and let's again conduct the quiz. Let's see whether we can get 100%. And to my surprise, that 98% just still remained close to 98. It was still around 99. And I was like, okay, I just give up. I raise my hand. I'm not going to do this. There are always some 1-2% kind of idiots out there, or stupids, who are not going to listen to what I'm going to say. But it's okay. So that's how the life is. Okay. So anyways, let's do this question now. And what do we need to do? What do we need to do out here? Oh my God, ask me, pakka, ask me. I'm pretty sure next year when you're going to learn under me, you are going to be that 1-2% who is going to do a lot of kida. I know that. You are going to do a lot of kida. I'm so scared now. Acha. So, this is a 3/4 circle. This is a quarter circle. 3/4 circle. This is a quarter circle. Well, Sneha, no. Unfortunately, we cannot do quizzes here. But on the paid platform, definitely we can do a lot of quizzes. Okay. So, what do we need to do, guys? 3/4 of that circle, right? Acha, because of this part, what is the magnetic field? Well, that's going to be mu naught I by 2 times of radius. 2 times of radius, all right, multiplied by 3/4 of the complete circle. So it is 3/4. So that's one contribution. Next contribution, because of this part, this is 1/4 of that complete circle. So it will be again mu naught I, but be careful, the radius is going to be 3r. R plus 2r is 3r. A lot of people are going to think it as 2r. So mu naught I by 3r multiplied by 2, that's same 2, all right. But this is 1/4. That's it. So add both of them and you are going to get the answer. So just add both of them and see where are you going to get it, and use your right hand rule. By the way, these things are irrelevant. They will not give any magnetic field at point O because they are along that line. So if you take a wire and if you measure the magnetic field here, because of that wire, the B value will be 0 because of this wire. Okay, because of this wire. Keep this in mind, very important concept. Okay, very good. No minus, be careful, it's not minus, it's plus, because the red wire is going to create a magnetic field like this. The green wire is also going to create the magnetic field like that. It's not going to be minus, be careful. No, it's not going to be minus. A lot of people make a mistake and they'll get a different answer. Okay, yes, that's what is very important. Yes, correct, Deepika. For the straight wire, theta will be not more than 0, I would say. When you are on this, see, the magnetic fields are always around the wire, not on the wire. So that's why it is 0. Okay, keep this in mind. Very good. Oh, that other arrow is not visible. See, if the current goes like this, it has to go through this. It has to go through this like this and come back over here. So even if this arrow is not given, it is understood that the current is going to flow like this only. Okay, so it is understood. So that's why both of them will add and you are going to get this particular option. Very good. Doesn't matter, Priyal, whether it is Irodov or non-Irodov, just get it. Okay, so here is the correct answer. Like most of us saw it, and let's move ahead to the next one coming up on your screen. 2 long wires which are at a distance of 2d. They carry currents flowing out of the plane, that means towards you. As shown, the variation of the field along xx prime is. Now if, see, what is this basically? There are 2 wires. I hope you can visualize 2 wires. You see what is the field here, 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 here. So you go from minus infinity to plus infinity. So at every point, check what is the field, and if it is upwards, it is positive. If it is downwards, it is negative. So let's see how many of you are going to get it. Okay, so it's not exactly downwards, Ramki. It was supposed to be inwards. So I think that what they meant was, you are looking at the diagram from the top, so it is inside the plane or down. So that's the meaning of it. Okay, Sanjal, I hope that is clear. Okay, it was not exactly downwards, it was supposed to be inwards. So kind of printing mistake out there. Okay. Well. Asmi, I'm not sure if I'll be free at 10 o'clock today. Okay. Wow. Glad, Abhi, you're in 9th and you're able to understand. I'm so glad. And I'll be seeing you again after 2 years in regular sessions as well. Glad to have the fan following from 9th itself. Why mu naught? Okay. Come on, minions. Let's see how many of you are going to get this. Oops. Okay, let me just drink some water. It's also time for you guys to freshen up, drink some water. Okay, a lot of you are saying A. Sir, you are having Apple phone. Yes, Sakti, I have an Apple phone. Okay. Now let me tell you how to do this. No tea. That's me. No tea. Oh, another new bottle. Yes, Andrew. Glad you guys are noticing. Okay, so how to do this? Basically, what you need to do, because of this wire, okay? Like, let's do this, guys. I mean, come on. So there is a wire coming towards you, and there is another wire coming towards you over here. Okay, so this is the center point, somewhere in between. Now, because of this wire, use your right hand rule and you will see this. Hold your thumb towards you, you will see the fingers curling anti-clockwise. So you will see the magnetic field lines will go like this, and as you move away, all right, this magnetic field lines will be like this, okay, and as you move even away, the magnetic field lines will be like this, okay. So this is how the magnetic field lines due to this wire are going to look like. Similarly, because of this wire, again, if you hold your thumb like this, fingers curl anti-clockwise, so it's going to be like this, okay, and then because as you move away, all right, still it will be circular, it will be anti-clockwise only, all right, and as you move more away, it will be like this. Now this is more than enough for you to figure out how it is going to look like. I hope you can realize that there is somewhere between these two wires where both the green and the red lines cancel each other, so the field must be zero somewhere. Do you see that? The field must be zero. Yes, the class is going to be till 9 o'clock around. So the field must be zero. So option B is eliminated, and even option C is eliminated because it is not zero at the midpoint. That is gone. Now, if you look on the left side, if you see all the lines are pointing downwards, and if you look at the right side, all the lines are going up. So on the rightmost side, the field must be up, means positive, and on the leftmost side, the field lines are down, that means negative. So out of available options A and D, do you see it is in fact wrong in option D? Do you see that? On the leftmost side, the field is positive here, but actually we know that the field is downwards, negative, and on the rightmost side, field is positive. So obviously the only option left is A, and you can see it works over here. Yes, very good, very good. Excellent. This is how you need to solve these kind of questions. A lot of people find it difficult. By this method, drawing these circles, very hypnotizing, you can get the answer. Okay, so that's the correct answer. Very good, minions out there. Alrighty, let's move ahead to the next question. Very good, very good. And here comes the next question. Now, this is very tricky. It's not so easy. Let me tell you that in advance. Okay, so Mudit, NCERT is good till one level, but you need HC Verma. NCERT is okay for boards, obviously sufficient for boards. It is required, but it is not sufficient. Alrighty, let's see how many of you are going to get this. It is going to involve some bit of derivatives and integration. I'll tell you what, this is not a quarter of a circle. It's not. The radius itself changes with theta. So radius changes with theta. The question is, what is the magnetic field due to this current carrying wire? Let's do this. Andrew eliminated C and D because the magnetic field did not become zero at the midpoint. They should cancel each other, but in those graphs, it was not even touching zero. It was close to zero. So that's why I eliminated B and C, Andrew. Okay, attitude level, please don't make me feel more bad. Okay, now I'm started to miss my cup of tea and coffee because tonight I had actually planned a late night drive. So maybe I'm going to have coffee after the class, after the marathon, but not now. So I'm going to go for a late night drive today, not now. So I skipped my cup of coffee with you guys. Okay, chalo. Let's do this now. Let's do this. So what you need to do is, due to each part, you need to find the magnetic field. Due to each part. Each part over here, let's say from here to here, all right? And let's say at the center, okay, it is going to subtend some angle, and that angle will be d theta. How much angle is it subtending? D theta. So due to that small element carrying current, this is an element carrying current I. What is the magnetic field over there? That's very simple. That is going to be dB. Correct? Magnetic field due to an element over here will be dB. This is like an arc. No, it's not going to be 0. It's going to be a very important question today. Please pay attention. This kind of question, if it comes, it is going to decide whether you are going to get 99 percentile above or not. So if you want more than 99, more than 98 percentile, then you need to solve this question. So pay attention. This is going to be a very important question. Now, the standard formula is mu naught I by 2r, right? But when it's a small arc, it is the angle subtended divided by total angle. So if one circle gives you this magnetic field, this d theta will give you this much magnetic field. This is the standard formula. Now, the value of r is also given. Let's substitute it. So I'm going to get mu naught I, all right, 2 2s are 4 and 4 pi. And I will have d theta, and over here I'll have b plus c by pi theta. Now this is a very good form. It's a sundar form. It's a very beautiful form where you can actually integrate this. Because when you integrate this, you are going to get the total field. This dB is because of this element. Each element will give magnetic field which is at different R's. So adding all their dBs, I will get the total field. So I need to integrate this and this. These are all constants, so I have thrown them outside the integral. So on the left hand side, I'll get net magnetic field. This is mu naught I by 4 pi. Now if you're wondering what is the integration of this is your standard form, dx a plus bx. What is the integration of dx upon a plus bx? Isn't it ln a plus bx, the whole thing divided by b? All right, isn't it this, guys? I hope this is clear. Very important integration formula. We'll put the limits, hold on, we'll put the limits, but this is something which you should know. So we'll put the limits. Now the limits are going to be from 0 to pi by 2, because this is 0 and slowly the angle is going to go till pi by 2, 90 degrees. Okay, so this will be ln, put that coefficient of x, which is c by pi, below. So c by pi comes over here. Okay, ln b plus c by pi into theta. Now this should be within the limits of 0 to pi by 2. Okay, so this is within the limits of 0 to pi by 2. So now let's see what to do next, guys. So the next step, b will be equal to pi goes, oh, this pi and this pi gets cancelled. You can see that this pi and this pi gets cancelled. So I'll be left with b is equal to mu naught I, okay, by 4 times of c. Okay, now put the upper limit first and then the lower limit. So put pi by 2 over here. So it will be ln, all right, b plus c pi by 2, and that pi is also there. All right, this thing minus, then put 0 over here, minus ln b plus 0. So that is what you're going to get. Now this is going to be mu naught I by 4c. All right, now pi goes, and what you will be getting is ln b plus c by 2. Log a minus log b is log of a by b. Remember that? So log a by b. So this is ln of this divided by this using the principles of log. So it will be mu naught I by 4c, and you will have ln 1 plus c by 2b. That should be the answer. Is that clear? Is that clear? How many of you understood this now finally? Got it? It's got beautiful mathematics inside of it. It's got beautiful integration out here. and it's got beautiful concepts, and it is going to be a deciding problem whether you are going to get it. Oh, no problem, Virat, you will learn integration and derivatives once you enter into 11th and 12th standard. So beautiful question out here. So that's the correct answer. Mu naught I by 4C ln 1 plus C by 2B. Beautiful. Very good, Sanjay. Very good, Sadhan. Very good, Nancy, Sakti, NVD. Very good. Excellente. Too tough, Aditya? Well, that's why it is a decider problem whether you're going to get 99, 98 percentile above. So if you want to aim that high, you have to solve these kind of questions. Very good, Ajay Kumar. Very good, Manuelite. Very good, Jasima. Beautiful. Yes, it is. Yes, after getting it, it feels easy. That's how questions are. Okay, next question coming up on your screens is this one. The two particles of equal charge being accelerated through same potential difference enter uniform perpendicular. Transverse means perpendicular field, and they go in circular paths. Standard. If you remember the formulas, this question is going to be easy. So if the radii are R1 and R2, what is the ratio of the masses? Let's see how many of the minions are going to get it. Come on, use your rough book, use your rough paper, keep your pens out. Keep solving, you have to get the answer and post it very soon. Let's see, it's like a stress test because in the exam also it's a competition. At least here there are few hundred students. In the actual exam there are going to be millions of students and you need to compete with them. So let's see how well you can compete. Come on guys. Oh my god, Asmi. Well, how many Vedantu t-shirts I have? Well. Let me count. 1, 2, 3, 4. One is spoiled, so actually I have 3 or 4 only. I think one I got recently more, so I think around 3 or 4. I have not counted it. Okay, so oh, attitude level, chill. It's okay. Haters are always going to be there, and you know, when I have people who hate me, I know that I'm doing right. Yes, I know I'm doing right because there will be always people who will hate me, and the best part is there will be always people who will be loving me, and when I see those people who love me a lot, that's when I know I'm doing things right. When I look at the hates, yes, it's okay, I ignore them. Oh my god, Asmi again wants a t-shirt. Alright, let's do this. Okay, A, C, B. Well, I'll tell you what guys you need to do over here. Well, they are accelerated by the same potential difference. So if you take a charge Q and accelerate it with potential difference of V, then it will gain some kinetic energy, which is half P square. P is the momentum by M. Alright, this is a momentum formula. So the electrical energy is going to getting converted into kinetic energy. This is what it says. So from this, I'm going to get the momentum is equal to root of 2mqv. So this is the momentum formula. Great. Now the next thing that I will use is radius. Radius is mass into velocity by qb. This is not potential, this is velocity. What is this actually? This is nothing but momentum. Correct? Mass into velocity is nothing but momentum. This is standard formula which I made you learn at the beginning of the class. Therefore, R is equal to P by QB. But hold on, P is already given. So why not just substitute it? So it will be root of 2mqv divided by QB. Now, if you square both sides, you will get R square is equal to some constant multiplied by M. So basically, can you see from here, R square is directly proportional to M. Therefore, isn't M1 by M2 going to be R1 by R2 whole square, which is going to be option B, guys. That's it. Very good. Now a lot of people I have seen in ratio and proportion problems, what they do is they end up finding the formula of M1 by M2. They'll actually substitute M1 on the top, M2 on the top. They'll keep substituting, they'll keep cancelling, and then they get the answer. That is a bullshit. That is a horrible method of doing it. Please do not do that. Please first figure out what is the relationship between the given and the required quantity. And then just divide it to get the answer, because everything else is going to be a constant. So do not sit and cancel out things. It is unnecessarily going to be very complicated. Alright, so that's the correct answer, guys. Option B out there. Very good. Well, let's get going to the next one. It's not a chemistry question. Sir, theory done or only questions? Shield gaming, the theory was done at the beginning of the class at 7 o'clock till 7:30 around, and then post that we have started with the discussion of questions. So attend this. After the session ends, you can definitely watch the theory part. Okay. Joshua, please, why don't you post it up on the comment section after the video, or just ping me on Instagram. I'll definitely help you out in detail. Okay, so because right now I'm in the flow of discussion, so please ping me on my Instagram handle or just post it out. But looks like a very good percentile, Joshua. You should start preparing for JEE Advanced. Fill up the Eklavya batch details which are there in the description box. It's a free batch for starting the next preparation for JEE Advanced. All right. Okay, Asmi, bye bye. Take care. All right. Let's see how many of you are going to get this. This is not such an easy question. Now, well, Rajshekhar, I would definitely love to launch that show. I mean, I would love to do that. And if you want me to have coffee with Shreyas, and maybe you want to be one of the guests and you have some talent and you want to showcase it, I would love to host some of the kids on this channel, and you can show this, showcase your talent, or even maybe on my Instagram handle, you can come, maybe you can do a live session or something on my Instagram, and you guys can showcase your talent. And if you want to do that, please let me know in the comment section below, and definitely I would do it. Abhishek, I'm sorry बच्चा, मेरे को भले ही हिंदी आती है, ये जो चैनल है ये इंग्लिश चैनल है. There is a separate Hindi channel also. Okay, so there is a Hindi channel which is called Vedantu JEE, just Vedantu JEE. So that's a Hindi plus English channel. Okay, come on, let's do this now. Okay, enough time given. A lot of you are still stuck, I guess. So the logic behind this question is, the two wires which carry current will experience repulsive force, all right, repulsive force due to the magnetic field, each other's magnetic field. Remember, two wires carrying currents can attract or repel each other, but since they are away, obviously they are repelling each other like this. So that is one thing which is very clear. Next thing, there will be tension over here, and there will be the weight. All right, now what is the weight? Let's come to that. Now just imagine that wires which are there. All right, so this wire looks like this in 3 dimensions. Let's say this is the length of the wire. All right, this is that cross section of that wire. So then the weight, all right, will be equal to mass into G. Okay, weight will be equal to mass into G. But what will be the mass? For that, use this fact. Lambda is mass per unit length. So use this. So it will be mass per unit length into the length into G. So this will be the weight of that particular section which you have taken, that small section of that wire. Now, after this, what you need to do, what will be FB? Well, the value of FB, guys, think about it. The value of FB is, I just told you, force per unit length. What was the formula? What was the force per unit length formula? Wasn't it mu naught current into length? So that was force per unit length actually. So total force will be into that L divided by the distance between them. Remember that distance square or just distance. I think it was just distance. Yes, divided by just distance, and there was 2 pi over here, mu naught by 2 pi into the distance. Now what is that distance? Think about it. What is the distance between the two wires? Well, this much is L sine theta. This is L, this is sine theta. This is also L sine theta. So it is L sine theta plus L sine theta. So it will be 2L sine theta. I hope this is clear. Very good. Man, hold on, bacha. Hold on. Yes, Shreyas will be starting 11th standard classes as well very soon, because right now your board exams are going on. So that's why we are kept it on hold. All right, the board exams will go on. Only post that we'll do something, or before that also we'll plan some things. Now, the next thing that you need to do is balance the forces accordingly. So if you draw a vertical line, this is theta, guys, because this is theta, even this is theta, even this is theta. So T's cos theta component and T's sin theta component is what you need to balance. So T sin theta. So the tension's sin theta is being balanced by FB. Is being balanced by FB. All right. So therefore, T sin theta will be this whole value, which is mu naught I square L divided by 2 2s are 4, so 4 pi and L, all right, and I have sine theta also, and I guess this value of L will get cancelled from numerator as well as denominator. This was in X. Similarly in Y direction. In the Y direction, T's cos theta component, all right, T cos theta component will be balanced by the weight. And what is the weight? The weight is nothing but lambda L G. Now what you do, take this and divide both of them. Just divide both of them and see what do you get. So T sine by T cos, well, it is just sine by cos, which is going to become tan later on, is going to be mu naught I square divided by 4 pi sine theta, and you have over here lambda L G. Now just rearrange this and you are going to get I square. So I square is going to be 4 sine square theta, all right, 4 sine square theta, then you have pi lambda L G, the whole thing divided by cos theta, and you have mu naught. That's it. So that is I square, so I will be root of that. I hope this is clear. Yes, attitude, definitely. That's why you guys are here, I know that, definitely. So, okay, I hope this is clear. Very good minions. So just, I'll repeat what we have done. We have figured out what is the repulsive force, because these are two current carrying wires. So repulsive force is mu naught I1 I2 length divided by 2 pi distance. Distance by geometry is 2L sine theta. There is tension in the wire. Alright, and the weight of that particular section is mass into G. Mass is mass per unit length into length of that wire. Now just resolve the forces in X and in Y. X direction, you have T sine theta balancing this magnetic field force, and Y direction, T cos balancing weight. After that, it's pure maths. Just divide it and just rearrange to find out the current. You will get the answer. Okay, Abhishek, I hope this is clear. So Jyotsna, last part what I have done, I just rearranged it. So I wanted I square because the question is what is the current. So put mu naught below, take all these terms over here, sine into sine, sine square, 4 goes there, pi, lambda, L, G, all have gone there. Okay, I hope now it is fine. Alright Jyotsna, I hope it is clear. Alright, very good Sadhana, very good Nancy, very good, excellente. Okay, now I hope Anuj Gamer, it is clear. Very good Priyal, very good Ajay. So very good question. So these questions have been chosen just so that you get a very strong hold of the concepts, and you can see the correct answer is this. So when you take the root, you will get this answer. Because there are sine square and 4, they will come outside the root. So that's why they are outside out here. Very good Aditya. So guys, please play it once more, alright, so that you will get a hang of it. This is a very good question. I have explained it in detail. Wherever you feel that, okay, I need to go slow, so there is always an option available that you can always watch it at a slower place after the lecture is over. Okay, Anuj? So watch it later on, because I have kept the pace considering in mind average student. Alright, so if you want to watch it slow, there is always an option after the session. Okay, next question. A small circular loop of conducting wire, radius A, carries current I. It is placed in uniform field perpendicular to the plane. Now this is a current carrying loop. It behaves like a magnet, believe me. Alright, now if you tilt it a little bit, it will oscillate. Yes, it's going to oscillate. So if you take a coil carrying current in a magnetic field, it would love to be somewhere. But you tilt it, there will be a torque which will restore it, and it will oscillate about its diameter. The question is, find the time period of the oscillation. Let's see how many of you are going to do this. Guys, beware of virus and report it. Okay, come on minions, come on, very good 88FF. Come on minions, let's do this. Come on. Let's do this. Rajshekhar Nange Kannada Swalpa Gottu. Okay. Come on, let's do this question. Okay, let's do this. So guys, report the virus out there. Okay. And Manmohan Sharma, you have been blocked because you are an idiot, you are a fool. Okay, that's why you have been blocked. Okay, so now let's do this question. Let's do this question. A lot of you are saying A or C. Some of you are also saying D. Okay, well, I'm giving you some time because I know that this question is going to take some bit of time, maybe 30-40 seconds. So take that time. Let's see how many of you are going to do this. Very good. Some of you are saying C. So then saying A, Aditya saying C. Well, I'll tell you what. Let's do this. Let's do this. Okay. Well, forget the options. Well, this current carrying coil, alright, that coil will have its own magnetic dipole moment. And what is the magnetic dipole moment of that coil? M, which will be N is 1, current, which is I, into area. What is the area? The radius of that loop is A, so pi A square. So that is the magnetic dipole moment. Now, visualize this. If this is the coil, this is the diameter. Okay, if you rotate the coil, all right, by some angle, that coil will experience some torque, and that torque is mb sine theta. But for small angles, because it is rotated slightly, that means the torque will be mb theta approximately, because sine theta will be theta for small angles. Very, very important. Now, once you get this, just substitute the value. So you will get I pi a square into b into theta. So the torque is proportional to theta. That means just like yesterday, if you remember, yesterday also a similar problem came. Whenever force is proportional to x, that constant of proportionality is spring constant. Whenever torque is proportional to theta, that constant of proportionality is equivalent of spring constant. I hope this is clear. This is basically equivalent of the spring constant. So guys, this is K equivalent because it is proportional. Now the only thing remaining is finding out moment of inertia. Now I hope you remember this is the diameter. So what you should do is basically, because it is rotating about the diameter. Remember, you have to use perpendicular axis theorem to find the moment of inertia. We all know the moment of inertia formula about the central axis. It is nothing but mr square for a ring. Now this ma square will be the sum of the other two moment of inertias. This moment of inertia and this moment of inertia about the two diameters. They are two symmetrical lines. So the moment of inertia is about this diameter or this diameter will be same. Using perpendicular axis theorem, this will be I plus I. Therefore, I is equal to ma square by 2. Now, the only thing left is, remember time period. Just like time period is 2 pi under root mass by k, here it is moment of inertia by the spring constant or by the torque constant. This is that formula. So just substitute it. So 2 pi under root moment of inertia is ma square by 2, and the equivalent is I and pi and a square and b. That's it. I pi a square b. So just cancel out few things like a square and a square will get cancelled, and 2 pi can be taken out inside out here by squaring it. So do that and you will get the answer. So it is going to be root of 2 pi m, because one of the 2 and one of the pi will get cancelled, and I and then b. Just check this out. Yes. So Mayank, you need this because this is actually going to come. These kind of questions are actually going to come. These are good level mains question. If you want 98 percentile above, you need to solve this. If you don't want 98 percentile, then ignore it. Okay, so these are, so I have kept all kinds of questions today, simple questions, moderate questions, and even difficult questions. Okay, clear? Very good minions, very good minions. Let's go ahead. So, how many hours I used to study? Jai Krishna, I used to study for more than 10 hours. Okay, when I was your age, I used to study that much towards the end of the studies. Alright, so Rajshekhar, I'll just tell you what has been done. First find the magnetic moment. This is a coil. Next, it's kept in field. So find the torque. So the torque when you rotate it is m cross b. And since it's a small angular displacement, convert sine theta into theta. That's it. Remember one thing very clearly. When force is proportional to x, that constant is k, time period is 2 pi under root m by k for normal linear SHM. But for angular SHM, the time period is 2 pi under root moment of inertia by that constant k which comes in, torque is k into theta. So this is the logic. Is that clear? Okay, very good. So this is how you need to do this. Okay, let's go ahead. I hope everybody is understanding this. Clear? Yes, Abhishek, it's a nice question. I know. Very good, Priyal. Very good. Okay, let's move ahead to the next one coming up on your screen. Let's see how many of you are going to get this. Solenoids, coaxial solenoids, forces F1 and F2 are there. Which one of them will be 0 or not 0? What do you think? Come on, this is a not so difficult one. This is an average level question. Come on, this is average to easy level question. You should get it very easily. Let's see, minions. Come on, minions. Show the Josh. Come on. Coaxial means two cylinders are coaxial, one around the other. So there is a cylinder like this, another cylinder around that. Both of them have the same axis. Okay, that's what is the meaning of coaxial. Okay, a lot of you are saying C. Okay, I don't know whether it is C or not. Come on, minions. Giving you some more time, last few seconds before we go ahead. Come on. Okay. A lot of you are saying C or D. Well, the correct answer is actually, I'll tell you what. See guys, inside a solenoid, the magnetic field lines are parallel, correct? Uniform. So the magnetic field lines are going to look something like this. Okay, so the magnetic field lines are going to look something like this. Now, if you take any element which carries current, okay, so let's say this is one length over here, you take a length over here. So try to visualize this ring which is placed inside the solenoid. All right, the coil is like that. Let's say the length is coming towards you. Let's say the magnetic field is there. All right, length is towards you, magnetic field is over there. The magnetic field lines are going like this. The ring is like this. So every element will be like this. Okay, so these are different elements. The force acting on any element will be I, L cross B. L is towards you, cross B. So hold your right hand towards you like this, hold it like this, length coming like that, length cross B, the force is going to be downwards. So think about it. So on every element, the force is going to be like this, then like this, then like this, then like this, and then like this, and then like this. So you will see that the net force is 0. All these forces are going to cancel out each other. Check this out. Think about it again. Guys, focus on the session. Attitude level, Nancy, come on, focus on the session. Look at this. All the elements will have forces directed inwards or outwards, and all these forces are going to be like that, and they will cancel out each other. Now, if the forces are going to be cancelled, so the reaction will also be 0. So if the outer solenoid does not apply any force on the inner solenoid will also not apply any force on the outer solenoid. Action, reaction. That's it. So the net force will be 0. That's the answer. As simple as that. Many people are going to fail in this question. I know this. It's a very beautiful, interesting question. Correct, Amrita. Very good. Very good. Yes, Aditya. Correct. Very good, Sanjay. Next question coming up on your screen. EMI. Determine the direction of induced current for the following situations. Come on. What is the direction of the induced current? Clockwise, anti-clockwise. Come on. Both the answers I want for A and B. Let's see how many of you are going to get it. Clockwise or anti-clockwise, clockwise or anti-clockwise. Two magnets are being moved inside or outside the coil. So we've got to use right hand rule, I, L cross B. If that wire loop is like this, if you take an element here, use your right hand, I, L is towards you, cross B. So the thumb points downwards. So that's why the force is like this. So every element will have a force towards the center, so they will cancel. Anti-clock, clock, clock, anti-clock. Come on, 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 come on. Yes, let's see how it will be. Well, guys, it's not that difficult. Come on, Lenz's law. Okay, so first of all, here the flux, think about it. Here the flux is increasing. So according to Lenz, what should happen? The current should oppose the flux increase. It should try to decrease. So to decrease, to oppose the increase, what will happen? The flux will try to decrease in this direction. So it will create a flux. This is opposing flux. This is opposing flux, preventing that increase. So to create that, use your right hand. Place your thumb in this direction. You will see the fingers will curl like this. So the current will flow this way to create, this is induced current, to create this opposing flux to resist the change. That's it. Very good. Very simple. Next up over here. Look at that. This is the North Pole. This is the South Pole. The magnetic field lines are going like this, but the magnet is being moved away. So as it moves away, the flux in this direction is going to decrease. The flux is going to decrease. So because the flux is going to decrease, what will happen? The induced current will create magnetic field to strengthen it. It is going to oppose that change. It's going to oppose it by strengthening it. So it's going to strengthen it because it is decreasing, it is weakening. So to create the magnetic field in that direction, hold your right hand thumb like that. Hold your right hand thumb like that. The fingers are going to curl like this, like this. So the current is going to go like that, which is clockwise. Understood? Understood? This is how it has to be done. Very good. So whenever it becomes weak, it strengthens it, and whenever it becomes strong, it weakens it. Very simple. You do this couple of times, believe me, you are going to get a hang of it. So anti-clock and clock as seen from this side. Okay. Next question. Now let's see. This is another important, interesting question, and let's solve it together. If the current in loop A, if the current in the loop A is decreasing with time, so look at this, the current in loop A is decreasing with time, then what is the direction of the current in loop B? These are two loops placed one over the other. Loop A is on the top, loop B is below. If you are looking at it from the top, in loop A, the current is flowing anti-clockwise. Visualize, if you have bangles or some rings around you, please use it. So imagine two rings like this, you are looking at it from the top, A is towards you, B is below. So the current is flowing like this in A. How will B's current be affected in both the situations? Once when it is decreasing, second time when it is increasing. What will be the direction of the current, and will they attract or repel each other? Alright, guys, let's do this. Let's do this. Very interesting question. After this, you will never face difficulty in Lenz's law. What you need to do is, very simple fact, guys. First think, how will the magnetic field lines look like? Because of this current. Which current? This current. So the current in this loop is flowing like that. Alright. So how will the magnetic field look like? So let me draw it first. So field lines are going like this. My thumb points the direction of magnetic field. So it should go outwards. So rather upwards. So it should be like this. And it will come from below, obviously. So it is going to come like this. Okay. So it's going to come like this. Okay. So this is how the magnetic field is going to pierce these loops. Okay, so this is how it's going to come. So I hope this is clear. So these are the magnetic field lines. Now in the first situation, the current is decreasing. Very important. If the current decreases, the flux will decrease. Check this out. That flux which is there, the flux which is in that direction will decrease. So according to Lenz's law, because it is decreasing, what will the induced current do? It will oppose the change. So to oppose, what will happen? It will increase its strength. So it will strengthen it. It will strengthen it. So think about it. This loop will strengthen that magnetic field. So curl your fingers such that the thumb will strengthen these blue lines. So support that blue lines. So the fingers will curl like this. So that means the magnetic field lines will be, the current in the coil will be this way. Isn't it anti-clock? Isn't it anti-clock, guys? I hope this is clear. Everybody understanding it? Now, what did I tell you some time back? This current is also flowing anti-clock. This is also flowing anti-clock. When two currents are flowing in the same direction, so when direction of current is same, what will happen? They will repel or attract. No, it's not going to repel, it's going to attract. Keep this in mind. Okay, same direction, attract, opposite direction, repel. Very good. Yes. So Jyotsna, focus on this now. You can always replay back the previous part again. And if you still have doubt, ping me on my Instagram handle. Definitely I'll help you. Or post a comment after the video ends. So for the second part, it will be exactly opposite. Because for the second part, what is happening? The current is increasing. Like the current is increasing, what will happen? The flux, which is pointing upwards, will also increase. And the flux increases, what will happen? To oppose, just write it down few number of times for few problems till you get it. It will try to weaken it. It will try to weaken it. So to weaken it, you have to create magnetic field down. Hold your right hand thumb down. Fingers will curl like this. Fingers will curl like this. So that means it should be this way. It is going to be clockwise and therefore it's going to repel each other. That's the answer. Is that understood? Finally, I hope you got an idea. Very good. Excellent, guys. Okay. Very good. Okay. Very good. Very good. Excellent, guys. Shall we go ahead? So beautiful question. So clockwise, anti-clockwise, both of them, we got it correct. All right, very good Mayank, very good Abhi, very good Sakti, very good Sanjal, Aditya. Come on minions, show some love. Thoda energy kam ho raha hai, thoda you guys are low on energy. Don't get stressed, guys. I am there for all of you. Tomorrow also I'm going to come, day after tomorrow also, and we are going to be there forever. This is a relationship we are going to build, not just before mains or before advanced, even after advanced. You guys are always welcome out here. Okay, chalo. Okay, questions bade hai isliye. That's why Aditya, I want to explain a lot of concepts through these questions, because after this session you are going to feel confident. You are going to remember, acha, Shreyas Sir told this to do. When somebody tells you, no, it is very easy. Imagine the same things. Oh my God, I showed you the answer. Something is wrong today. Anyways, so if you study the same things on your own, it's going to take maybe 3 hours. But here it will take 1 hour or maybe half an hour. So when somebody explains it to you, it is easier. You save a lot of time. That's why we are here. Or else I could have just given you, these are the notes. Come on, study on your own. What is the point? Okay, so the correct answer is B for the next question. I'll tell you why. See guys, if you have a copper ring, a wooden ring, same length, same dimensions, etc., and placed in changing flux, where will there be EMF and where would you have current? Now let me tell you guys. First of all, this wooden ring is an insulator. Please understand, this is an insulator. Copper is a conductor. Keep this in mind. This is a conductor. So the moment you have changing flux, maybe because of changing field, so be it a copper ring, be it a wooden ring, EMF will be there. Why? Because it is d phi by dt. So EMF will be there, d phi by dt. So there will be EMF in both of them, but current won't be there, because in copper wire, all right, the current will not be zero, but in wooden wire the current will be zero because it's an insulator. So no current will actually flow in spite of voltage. So it's like connecting a battery across a wood. Nothing will flow. There is EMF but no current. But in copper, current will be there. I hope that makes sense. Okay, let's move ahead. Let's move ahead. Yes, yes, let's do this. Okay, okay. Attitude level, do not fight out here. Okay, so make sure that you guys maintain the calm. Okay, so chill, and yeah, please don't fight. Make sure you maintain discipline on the chat box, else the admin will have to block. Okay, cool. Forget it. You guys are all friends over here. You guys are lovely minions. We all love each other. We are all going to support each other. Make friends. All right. That's why you have attended this session. Okay, cool. Chill. Forget. Now do the next one. A loop kept so that the center lies. Very beautiful question. Let's see how many of you are going to crack this, guys. Let's see how many of you are going to get this. Come on, forget it now. Focus on the current problem. A loop is kept so that the center lies at the origin, and there is a field in the z-axis as shown. So z is in and out, x is right, y is up. Which of the following option is correct? Only one option is correct. Come on, come on, come on, come on, come on, come on. Aishwarya, no problem. Chill, 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 chill. Now he has apologized. Attitude is going to maintain discipline. Very good. Chalo. Everyday timing, Jaya, it's going to be at 7 o'clock. Okay. Anjani, my bacha, please don't give up, yaar. Why am I coming here? What has gone into me? I have come here only to motivate you, to make sure that you understand everything, to make sure that you learn. So please attend these classes live. Believe you can do it, and please contact me on my Instagram handle or leave a comment after the video ends. I'll definitely help you out. Okay, please Anjani, don't give up. It's not the time to give up. Please understand that. It's definitely not the time to give up. All right. C option. Well, the correct answer is actually C. EMF is induced and induced current also flows in the loop if it is made of copper and rotated about y-axis. Now this is very simple, guys. See, if you rotate it, then what will happen? The flux will change. And whenever flux changes, according to this d phi by dt, EMF will be induced. So that is very clear. So EMF is induced only if it is rotated, because only then the number of lines which will cut will change. And current will be only there if it is made of copper. Remember, you need a conductor for the flow of current. Hence, not necessarily copper, you can have iron, you can have aluminum, but some conductor. So the significance of copper here is just for conductor. Please understand, if you rotate it about z-axis, alright, if you rotate it about z-axis, then nothing will change. Because if the loop rotates like this, the flux piercing will always remain constant, it will never change. So you need to rotate it along x or along y. So keep this in mind. Okay. So this part is wrong. No EMF is induced, obviously wrong. EMF will be induced if you rotate it about y or x axis. Okay. So just now I said that, Suvarna, I told you that if you even if you do not have copper, it works as long as you have a conductor. Okay, I hope this helps. Very good, very good. Vishnu, bacha, I'll tell you what to do. Simple. If you're not getting enough sleep and stressed out, please start meditating. Number 1, every day in the morning. Also, do not think about others. Leave all the negative people aside. Also, just achieve small targets. Don't think about tomorrow. Don't think about the past. Always set a target for today. Next day you think about next day. Don't worry about the day after or day before. That's it. And just write it down in your notes or somewhere in the calendar that what you're going to do for the next day. That's enough. So you don't have to worry. So plan it out. Schedule small tasks. Stop looking at negative people or being around negative people. Meditate in the morning and do little bit of exercise, workout, or maybe play some musical instrument. Keep your mind fresh. Talk to positive people. Listen to positive music. Believe me, you will be getting good sleep. Okay? Chalo. Next question coming up on your screen. Okay. A metallic rod moves at constant speed in a direction perpendicular to the length. So which of the following is correct? Come on, let's see how many of you are getting it. Yes, G Devendra, why not? Please ask. In case if it is related to the portion right now, I'll definitely ask. Else you can put a message after the video ends. Okay. Come on, guys. Hardly next 3-4 questions. Simple questions are remaining. Only 3-4 questions remaining. Are you guys ready? Come on, let's be quick. Within next 5 minutes, we have to do this. Come on. Let's get going. Let's pump up. Come on, guys. Let's do this really quick. Come on. Let's do this. Hardly 3-4 questions remaining. Come on. D, well, the correct answer is actually B. There is an electric field inside the rod. I'll tell you how. You have to use this formula. Electric EMF induced, I've just given you the EMF induced is L dot V cross B. I gave you this formula at the start of the lecture. So it's mentioned that the velocity and magnetic field as well as the length are mutually perpendicular to each other. They are all perpendicular to each other, everything. Now if you do V cross B, check this out guys. What is V cross B? Use it, V cross B. V cross B will be there. This is V cross B. Now if you take the dot product of that, if you take the dot product, cos 180 will be -1. That means it will be there. So this value is not going to be 0. If this value is not going to be 0, that means there is induced EMF. There is induced EMF. I hope you can understand that. And if there is induced EMF, isn't there some electric field inside this? Because how will EMF come? Only if there is field. Field creates potential difference. Field creates potential difference. So that's why, because there is EMF, that's why there is field. As simple as that. Okay, very easy based on formula. Next question. There is a ring attached to a rod and it is freely moving like a pendulum. If there is a magnetic field which is applied in the direction so that pendulum swings through it, so that the pendulum swings through that region of magnetic field, what do you think will happen? Come on minions. Wow, very good. Shreyas Sir's army is also there. Yes, it can't be A as it is moving. Correct. Jaya, which book is beginner choice? Beginner choice is basically NCERT and HC Verma. Always go with that. Okay, very good Padmesh. Wow, very good. Glad you feel that, Jatin Verma. So glad. Lovely. A, B, Baby Bear says B. Wow, what nice names you guys come up with. Mayank says B. Sir, air resistance is neglected. Yes. Very good, Baby Bear. Very good, Sanjay. Yes, excellente. The answer is B. And the reason for that is eddy currents, not air resistance. Eddy currents. Because what will happen once it goes through the magnetic field region, the flux will not be constant. And because of the flux not being constant, EMF will be there. Because of the EMF, current will be there. And because of current, I square R, which is nothing but loss. Heat will be developed. And where will this heat come from? The mechanical energy. So it will eventually stop because of the losses in the eddy currents. Keep this in mind. Okay, very good. Some of you realized it now. Last 2-3 questions. Come on minions, let's do this. It's hardly going to take us 2-3 minutes, not more than that. The equivalent inductance of two inductors is 2.4 when in parallel, but 10 Henry when in series. What are the values of the inductances? Come on minions, let's see how many of you can do this very quickly. Within 30 seconds you should get this. It's a 30-second question. Come on minions. Yes, Jyotsna, leg damping. Very good Sanjal. Very good Aditya Thakur. So the current direction also will change, Rajshekhar. Yes, correct. Very good Deepak. Okay, Yalni. Very good Ajay Kumar. Come on minions. Come on, fast, fast, fast. Let's do this. Come on. Sanjay says B. Nancy says B. Abhishek says B. Divya says B. Okay. A lot of you are saying B. Well, actually, let's try this out. So when they are in parallel, that means it is 10 Henry. Okay. And when they are in parallel, my bad. When they are in parallel, it is 2.4 Henry and 10 Henry when in series. So very simple. So X plus Y, all right, is 10, all right, and XY upon X plus Y is 2.4. When in series, use this formula, addition, and when in parallel, L1, L2 upon L1 plus L2. Now X plus Y is 10, so it will be XY upon 10 is equal to 2.4. Now XY is equal to 24, and then substitute the value of Y from here. Y is nothing but 10 minus X, that is 24. So you will have minus X square plus 10X is equal to 24. So you will have X square minus 10X is, plus 24 is equal to 0. So you will have two roots, one will be 4, one will be 6. That's the answer. This is the answer. That's it. Very simple. Just use series and parallel formula. As simple as that. Very good. Very good. We can use option substitution also. Yes, Abhiram, you can do that. Okay. Chalo, next question coming up. All right. Come on, minions. Let's see how many of you can do this. Come on, second last question. This is the number of turns in a coil of a wire of a fixed radius is 600 and the self-inductance for that is 108. What is the self-inductance of a coil whose turns are 500? Come on, let's see. If the turns are 500, then what is the self-inductance? Come on, you should know the formula of self-inductance. Come on, come on, come on. Yes, yes, Jyotsna, you can do that. You can do it by options also. But please remember, never do it at home by option substitution. That's where you guys go wrong. What if the examiner has designed a question which takes a lot of time via option substitution? That's why you need to do it by method. This is a wrong way of solving at home, but in the exam, if it works, use it. Please keep this in mind. Okay. So guys, I'll tell you what. You should know the formula for inductance. Come on, what is the formula for inductance? Who is going to tell me? Who is the person who is going to tell me the formula for inductance? It's a very standard, simple formula. Come on, minions. Standard formula which I gave you just some time back. Mu naught n square length multiplied by area. So that's it. That is the formula. Very simple. That's it. Now do it. L2 by L1. Area is same because fixed radius. So fixed radius means area is going to be same. Only length is also going to be same. So N2 by N1 whole square. So L2, well L2 I don't know. L1 is 108 is equal to 600 by 500. So 600 by 500, the whole thing square. Just solve this and see what you get. I think you are going to get C. Yes, very good, very good, very good. So that's the correct answer, guys. Very beautiful. And last question coming up on your screen. The current in the primary of a car spark coil changes from 4 ampere to 0 ampere in 10 microseconds, as a result of which an EMF of 40 kilovolts is induced. What is the mutual inductance between the primary and the secondary coil? Come on, let's do this. Last question out here. Last question out here. Come on, minions, let's do this. Last question out here. What is the mutual inductance between the primary and the secondary coil? Use the formula. I just given you the formula. The induced EMF is mutual inductance times di by dt. Remember, I gave you this formula. Just use this. What is the induced EMF? It is 40 kilovolts. What is M? I need to find out. Change in current, 4 to 0. Just forget the signs. Just understand the change is 4. In how much time? 10 microsecond, which is 10 to the power minus 6. So M is going to be this 4 and this 40 is going to become like 10. So 10 multiplied by 10 to the power 3 multiplied by 10 multiplied by 10 to the power minus 6, which is going to make it how much? 10 to the power 4, 10 to the power 5, 10 to the power minus 6. So 10 to the power minus 1 Henry, which is option B. Correct. Yes. Yes. I hope it is clear. Yeah. Okay. So I think in the previous question, maybe I just wrote 600 by 500. All right. Or 500 by 600. I'm not sure. But I just repeat it for the previous part. All right. So for the, where is it? Yeah, for this part, yeah, it was actually L2 by 108 is equal to, the new radius is 500 and the old radius is, sorry, old turns is 600 and new turns is 500, this thing whole square. So solving this, you will get it. So I'll just correct it. Okay, I hope that is fine. So I think I missed one of the things, or maybe I wrote it opposite or something. So this is the correct way of doing it. Okay, cool. So that's it, guys, for today. And in case you are facing any difficulties and you need any assistance from Vedantu, we are here to help you with the crash course, with live classes, with the best teachers, with doubt solving and lots of test series. And these doubts will be solved from morning till night, along with 20 test series and obviously 45 live sessions, which will also be recorded with handwritten notes and also assignments which will be provided to you. So the crash course is starting now, all right? So please join it as soon as possible, because you are getting 30% off on the crash course. So instead of 10,000, you pay 7,000 rupees using the coupon code SHCC. So if you want more details about it, please ping me on my Instagram handle. I'll definitely help you out. Also, today's PDF will be uploaded on the Telegram group. So join the Telegram group without fail, and please like the video if you want to support me and if you want to express your love. And if you are new to this channel, do not forget to hit the subscribe button out there. Thank you very much for joining in. Tomorrow we'll be meeting again for a mock test discussion by all of us. Bye bye, take care, have fun, and please keep studying. See you guys.